I'm Anil Kumar, and in this video we'll explore and understand how to prove relationships amongst segments. Given C is the midpoint of segment AE and BD, where segment AE is congruent to segment BD. Prove that these two segments AC and CD are congruent. Let us first sketch and understand the scenario. We need two segments AE and BD, and both are congruent. So let us say that is one of the segments, and the other segment is let's say BD, and both intersect at C, and C is the midpoint of both of them. That means from the midpoint, which is common to both the segments, we have to go same distance away, right? Kind of like this. So that is how we can make it. So we have two segments here. Consider them to be absolute straight lines. The first one is AE for us, and the second one is BD. Their midpoint C is common. So C is the midpoint of AE and BD, where AE is congruent to BD. So these two segments are congruent segments. We need to prove that AC, which is this side, is congruent to CD. This is what we need to prove. So whenever we have geometric proofs, we should always adopt two-column proof. That is a formal method where we have two columns. Let's say these are the two columns. We'll write statements on one side, normally the left side, and reasons on the other. Let's begin with writing what is given to us, and that normally should be the first statement. So it is given that there are two segments AE and BD which are congruent. So A is congruent to BD. Then we have a point which is the midpoint for both of them. If C is the midpoint for both of them, then it is given to us that AC is congruent to C and BC is congruent to CD. So this is what is given to us. And we have drawn this from the midpoint definition, right? So that is also from midpoint definition. Now when these segments are congruent, we can write that their measurements are also congruent, correct? So we can say that AE is equal to BD, AC equals to CE, and BC equals to CD. Let me just squeeze it in here. Correct? So that is from the definition of congruence. So whenever we say that the segments are congruent, that means their length is exactly same. Now how to prove, now we know this, how to prove that AC is equals to CD. So what we can do is we can write AE as combination of AC and CE, right? So AE could be written as AC plus CE. Correct? AC plus CE, let me first write this as AE. And this we get from segment addition postulate. Similarly, we can also write BC plus CD. So we'll add here itself. BC plus CD is equals to BD. Right? Now, from 2, we know AE equals to BD. AE can be written as combination of these two segments. BD can be written as combination of the other two. So from 2 and 3, what can we write? AE equals to BD, that means AC plus CE is equals to BC plus CD, right? So that is from substitution of 2 and 3. Now, we are also given that C is the midpoint. That means AC is equals to CE, right? So AC is equals to CE, and also BC equals to CD. That is given to us, correct? So we are using the definition of midpoint, and so we can write AC plus CE as AC plus CE is equals to AC. So we can write this as AC, correct? Similarly, BC is equals to CD. So we can write this as CD plus CD, correct? So that is how we can write BC equals to CD. We can replace, so that is substitution. So we substituted what was equal, BC was equals to CD here. Now we can simplify and write this as 2AC equals to 2CD. If I divide both sides by 2, what do we get? We get AC equals to CD, and this is division property. Of equality. Now if measurement of the segment AC is equals to that of CD, then you can conclude that the segment AC is congruent to segment CD, right? So that is from the definition of congruence. So in these sequence of steps, we have proved that AC is congruent to CD, and that is how you can do it. Thank you and all the best.